This is the circuit that I have created for figure S1.1 using Vpulse with parameters. So this creates a pulse with an initial value of 0 volt, amplitude of 5 volt, a pulse width of 0.5 milliseconds, and a period of 1 milliseconds. So for rise and fall times at 1 nanoseconds and a delay to start at 0 seconds. So before I run the simulations, I will tick for the transient and the final time change to 1 milliseconds. So this is the graph that I get from the circuit for simulation 1 Rlc simulation, Rlc transient. And the number here as we need to record the time for this for the graph, so we use the toggle cursor and plot for the values for charging and discharging. So the value from here until here is for charging, and here until here is for discharging, for from pi until 5 pi. That's all from me. Thank you. Good morning to doctor. Today I'm Untitled Rachel. Today I'm going to explain the part A, which is Rlc transient simulation. So in this part, there are 3 simulations. So for simulation 1, which is Rlc transient. So in this circuit, because it's Rlc transient, so it only has capacitor in this circuit. The graph is what I get from this circuit. So in this simulation, it need to find the charging values and discharging values. In the charging values, the period pi, 2 pi, 3 pi, 4 pi, and 5 pi, the value I found in the graph for pi is 3.1576, for 2 pi is 4.3245, 3 pi is 4.7523, for 4 pi the value is 4.9092, and for 5 pi the value is 4.9668. And for discharging, the period is also have pi, 2 pi, 3 pi, 4 pi, and 5 pi. So the value for pi I get from the graph is 1.8240, for 2 pi is 668.771, for 3 pi is 245.205, and for 4 pi is 89.904, 5 pi is 32.933.
Very good morning to my lecturer and my friends. I'm Sudhakar Elango from Dual BEKG Section 4. So for the lab, I'm doing part B, resonance of Rlc circuit. So basically the resonance of Rlc circuit occurs when the reactance value of inductor and capacitor are same in magnitude, but they cancel out each other due to 180 degrees apart in phase. So for the circuit, it looks like this. So we have input voltage, which is AC, and then we have R, L, and C connected in series. So the value of C is 0.33 microfarad, inductor is 2.4 millihenry, and the resistor is 15 ohm.
First of all, we need to construct the circuit as following the time sheet. And then the component is V sine, which is the power source, R is the resistor, L is the inductor, and C for capacitor. G and D is ground connection. So we have to arrange the components as following. And then the voltage, power source, then we need to set AC is equal to 2, V off is equal to 0, and then frequency is 50. And okay, next we need to set up the analysis. AC sweep set for range 10 to 10k. Close, save it, next, simulate the circuit. So this is what the result that we get lah for RLC resonance circuit.
To draw the circuit as required in lab sheet, we need component as below. C is for capacitor, GND is ground, L is inductor, R is resistor, and V sign is our power source. Next is the resistance value directly input, whereas for the inductance or capacitance value, we need to calculate it to get the actual value of resistor or inductor. For example of case 1, we need to take the 240 to calculate by divide 2 and divide 50, which is frequency and also pi, and we'll get 0.7639. Whereas for the power source, we need to get the Vmax of the power supply, which we need to calculate with 240 Vrms times square root 2, and we'll get the 339.41. Whereas for the frequency is 50 and the V off is 0. And then we need to set for the analysis setup and set the transients. Then we can start simulate the circuit. This is our result. Any other case, just change the value or change the component. That's it from me.